Hey there, cybersecurity pros. Ever wondered how to turn a flood of data into a fortress against attacks? I'm Douglas Ann, and you are in the right place to unravel the secrets of Cortex XIAM analytics. This isn't just another tool, it's your SOC superpower. In the next few minutes, we'll tackle into the essentials, nailing down data collection, understanding the basics of security analytics, also the differences between correlation rules and analytics, and also advanced techniques to outsmart attackers. Stick with me and let's transform your security game together. So, in this session of Cortex XIM Analytics, we'll talk about data collection requirements. So, basically, what data is required to collect so we can make analytics work properly. We'll see an overview about analytics, what it is, how it works. Then we dive into more details, the profiles, the detectors, the differences between ABIOC rules and analytics rules, and also the differences between analytics and correlation rules. And then at the end, we'll talk about EAL logs and why it is important for XIM analytics. So, data collection requirements. For analytics to work properly, we need to collect data. And the more data we collect, the better, right? So the idea here is to collect data from multiple sources. The endpoints, using, for example, the Cortex XDR agent, from the network devices, like next generation firewalls, multiple vendors, cloud logs, so from your public cloud providers, like AWS, Azure, Google Cloud. Also, identity logs will be important, right? So logs from Okta, Azure AD, Office 365, Ping Identity, etc., and even other applications. So these data will get ingested into XIM, into what we call data sets. Then it'll be normalized, parsed, enriched, and then based on that, we have multiple detectors, right? And one of the detection layers we have on XIM is the analytics. So just to dive into more details about data collection, especially when you are collecting data from endpoints, right? With the XDR agent, we activate a function that we call enhanced endpoint data. This is part of the agent settings profile, right? The pro capabilities. But basically, when you activate this function, the XDR agent will start monitoring all endpoint activities, like files activities, process activities, network activities. So basically for files, right, it will monitor file creation, file deletion, when a file is read, modified, processes, it will monitor all processes running, right? So process execution, process ingestion, and it collects all the details of the process, right? The process name, process ID, the user under which the process is running, command arguments, for network connections, right? The IP addresses, communication ports, protocol path, if the traffic is incoming traffic, outgoing traffic, if the session was established or failed. For registry keys, right? It will monitor keys creation, deletion, keys modification, deletion. It also collects some Windows event logs for actually operating system logs, right? But specifically for Windows, it'll collect some different types of logs with the error message, with the event ID, user level, etc. And if you are collecting logs from other sources like next generation firewalls, right, we're going to get more details about these network connections, the app ID, the firewall rule name, the device ID, serial number, the session status, etc. And for authentication services like Okta, Azure AD, Ping Federate, right? It collects all these login events, user creation, deletion, etc. So here we have a list of all data that will be collected by the Cortex XDR agent. Now, XIM supports other endpoint solutions, right? Like CrowdStrike, for example, but in terms of details of data, right, the XDR agent will collect a lot more information. So as we saw in the previous slide, files activities, process activities, thread injection, registry activities. It also collects OS event logs. So for Windows, for example, it collects some application logs, not all, but some application logs. In the documentation, you can see all these details. Anti-malware specific logs. So if you have a Windows machine here that also have Windows Defender activated, for example, right? It will collect the Windows Defender logs, the Windows Firewall logs, and all security logs. So why is this important? Firstly, once the data gets ingested, right? Let me go back here. As we saw in this diagram, we have a function called event stitching, right? So the events will be stitched, associated, correlated, to tell the whole story of the attack, to provide the what we call the causality analysis. So once some event happened, right, some alert is triggered, all these metadata, all these telemetry, right, will be stitched together with the alert so we can see the whole story of the attack. This is very important. So about event stitching, let me give you an example. Pretty simple example. So let's say you are collecting the endpoint telemetry, right, from the XDR agent. So you're collecting all processes activities, files activities, register activities, etc. Let's say in my example, there's a malicious process running on this endpoint, right, and it tries to execute some suspicious activity. Then, based on the protections we have on the Cortex XDR agent, it will prevent the attack and trigger an alert. So based on these activities, right, the alert will be populated with the process information, the process activity. But let's say, for example, this malicious process initiated a network connection. So from the endpoint perspective, right, we can see that a process initiated a network connection. Some details like IP addresses and ports and protocol, but that's it. Right? If we want more details about this network connection, we need to collect the network logs, right, from especially next generation firewalls. Then the event stitching functionality will get the details of this network connection and put together here, stick together with the alert so we have more details. Let's say another scenario. This malicious process tries to access some cloud resource on your AWS VPC. If you are collecting the AWS audit logs, right, more details you're going to have. So what is this resource that the malicious process is trying to access? So it will stitch this information together here into the alert. So when you open the alert, right, you're going to have all the details about the attack. So the idea of event stitching is to tell the whole story of the attack. Okay, so the more data we collect, the better, because it will help XIAM to trigger high fidelity alerts. So on XIAM, we have AI and machine learning, so it makes extensive use of AI and machine learning on multiple features, right? One of the features is the event stitching that I was talking about. So we have multiple detector layers, over 5,000 detectors, and it makes use of more than 2,000 machine learning models, right? The idea here is to prevent the attacks in real time, to have a precise causality and detection, and the full context of the threats. Now, what is analytics? Analytics uses AI, right? It basically uses statistics, math, and machine learning to find patterns in raw data. So this is what we call a baseline-based engine. So there are many detectors, as I mentioned on XIAM, right? But many of these detectors use what we call a rule-based engine. So the detectors are based on rules. Analytics is different. It uses a baseline based engine. It means that it's going to learn from your environment, right? Define what is normal in this baseline, and then it will compare the data backwards with the baseline to identify any patterns, right, that are considered abnormal. So any anomalies, any deviations from the normal. So it is used as an additional layer in your cyber defense, creating a proactive defense mechanism against evolving threats and vulnerabilities. So it goes beyond traditional rule-based approaches, as I mentioned. So why should we use analytics? As I mentioned, right, on XIAM we have multiple detection layers, but they are most of them, right, are rule-based detectors. So they are basically static rules. If the attacker finds a way to bypass some of these detectors, then we don't have other layers of defense, right? So that's where analytics comes in. We have here detectors based on behavior. So anything that is suspicious, that deviates from the normal, from the baseline, may be identified as suspicious or malicious. So the Cortex XIAM researchers have published over 650 detectors, right? And this continues to evolve. And they provide new detectors based on engagements with customers, right? The Unit 42 team, and it's continuously evolving. Now let's go into some more details about analytics. I mentioned about this baseline-based engine. How does this work? So as part of the baseline building mechanism, right, we have these profiles. They are called dynamic profiles. So we can divide these dynamic profiles into three main categories: peer group profiles, temporal profiles, and entity classification profiles. So just to sum up in simple words, what these terms mean, right? Peer grouping profile uses a statistical analysis to identify entities that are common, or entities that have the same behavior. So it will group together entities with the same behavior. So let's say, for example, you have some workstations, right? On those workstations, you have two processes running, a parent process and a child process. So the analytics profile will identify if these two processes are also running on other machines, right? So we call this popularity. If we have the same processes running on multiple machines, so the same behavior for a period of time, let's say for 7 days, this will be grouped into a peer group profile. So it'll be considered normal. Next one, temporal profiles. So it's also a statistical analysis where analytics will compare an entity activity with itself over time. So let's say we have some activities executed on a workstation for like 1 hour. It will get this 1 hour slot of time and compare with the same entity over time, right? Like 7 days ago, for example, 14 days ago. If we have the same behavior, right, the same activities over time, so this is considered normal. And the last one is entity classification. So basically, with these profiles, analytics is able to distinguish between different entities, right? Different roles of entities. For example, it may distinguish a regular workstation from a server. It can be even more specific. So distinguish between different servers, a DNS server and a domain controller. Domain controller and a database server. Even more specific, SQL database or an Oracle database. Also for user accounts, right? It can distinguish between a regular user account and a privileged account, an admin account, or even a service account. So some of the detectors, right, may identify suspicious activity, but maybe if this activity is done on a DNS server, this is considered normal. But the same activity executed on a regular station may not be normal. So it gives analytics the ability, right, to distinguish different types of entities. Entities, by the way, could be endpoints, hosts, users, could be processes. So this is all considered entities. And so on analytics, we have these sensors or detectors. And every detector depends on some specific data. Even some will depend on multiple data, right? If you are not collecting that data, these sensors will just be inactive. So for analytics to work properly, as we saw at the beginning, we need to collect data from multiple sources, right? So here we have a list of Palo Alto logs, right, from different Palo Alto products, from the agents, from a Palo Alto firewall, like traffic logs, URL filtering logs, the EAL logs, as I mentioned. We'll talk about this in more details later. But also very important to be collecting logs from third-party systems, third-party firewalls, authentication services like IAM solutions, right? Okta, Ping Federate, Azure AD, etc. Windows event logs that collects logs from Windows servers, and many other logs, right, from third-party solutions. This will be very, very important. And all these detectors on analytics, right, will be created based on the TTPs, right? So the focus here is on tactics, techniques, and procedures executed by attackers. So you're going to see here the detectors where it will show you that it is covered by the MITRE framework based on the execution techniques, on the persistent techniques, discovery techniques, etc. So let me give you some examples here. Execution. Execution is a tactic that involves techniques used by adversaries to execute malicious code on target systems, right? The XIAM analytics will raise alerts, so it has detectors that will identify execution attempts, code execution attempts on suspicious processes. Let's say persistence. Persistence is a tactic that focuses on techniques where adversaries will try to maintain access to the compromised systems, right? So XIAM will provide you detectors that will identify the creation of persistence mechanisms in form of registry keys changes or scheduled tasks created, things like that, right? Lateral movement, where adversaries will try to move laterally within a network, seeking to expand the foothold. So on analytics, we have detectors that will identify these unusual authentication attempts from some unusual locations, trying to access some unusual file shares, and as I said, from unauthorized locations or odd locations. Okay, and so on and so forth. Every detector will be mapped to the MITRE attack tactics and techniques. Another important concept, also every detector will compare, right, the behavior, the recent behavior with log data expected in the baseline. So it always compares recent data with some data based on the baseline, right, that was established previously. So we have on these analytics detectors 4 time intervals: activation period, which is also called soak period, test period, the training period, and the deduplication period. So activation period is the time it takes for this specific detector to start triggering alerts. Test period is the slot of time that is used for comparison. Okay, we'll see here a diagram that explains that better. The training period is the baseline, right? So how long it takes for the baseline to be established. And the deprecation period is the alert suppression. So to avoid this detector on triggering too many alerts, there will be a deduplication period, right? So the minimum time that an alert to be triggered. So let's have a look in this diagram. You're going to notice on many analytics detectors that the soak period or the activation period is shorter than the learning period. So let's say the learning period to establish the baseline, it takes 30 days, right? But the soak period is just 14 days. Why is that? So it means that this detector will start triggering alerts even before the baseline gets established. Okay, so what ends up happening here, initially, this detector may trigger alerts, and these alerts may not have the highest accuracy. Okay, so it privileges detection over the baseline. Okay, but it requires a minimum amount of data, right? In this case, 14 days. So the more we are reaching the baseline, better will be the accuracy of this detector. Until we establish the baseline, then this detector will have the highest accuracy. And how to enable analytics. The process is pretty simple, right? As long as we are collecting the right data, we have enough data, then we can enable analytics. And as you enable analytics, it gives you the option also to enable the identity analytics. The identity analytics will provide additional detectors, right? They're focused on user profiling. So same idea, it will have specific profiles to learn from user activities, right? To identify malicious users' activities. That's the idea, right? So the basically it expands the UABA functionality on XIAM. But for us to enable the identity analytics, it's required to enable the Cloud Identity Engine. Cloud Identity Engine is another cloud service that can be integrated with XIAM, right? Think about the Cloud Identity Engine as your IAM hub, right? Where you integrate all your authentication services, so you can synchronize the domains with CIE, and then CIE will synchronize this domain information with analytics. So all users, groups, group membership information, computer objects will be all synchronized with XIAM. So to provide additional information about the users. So let's have a look here where to activate analytics. So here I have my XIAM tenant. So we go to settings, configurations, right? And we have an option here called Cortex XIAM Analytics. And as you can see here, right, it's already active. As I mentioned, it requires a minimum amount of data. So for endpoint data, for example, it requires 2 weeks of data from at least 30 endpoints. Otherwise, the option would be grayed out. You cannot enable it. Okay, and for cloud logs, it requires at least 5 days of logs. And as I mentioned, right, it gives you the option to enable identity analytics, but make sure you have all the requirements accomplished here, right? So you can click on learn more. You can see all the details about the Cloud Identity Engine. And back to the slide. So as you enable analytics, on analytics, we have some special detectors called ABIOC rules, right? On XIAM, we have BIOC rules, which is part of the rule-based engine, right? So they are basically static rules that will, as we have a match on the data, right, on some specific activity, it will trigger the alert. But they are pretty much static. ABIOC rules are like hybrid rules because ABIOC rules will take into consideration the profiles, the dynamic profiles. Okay, so for ABIOC rules, the baseline here works as a threshold for the ABIOC rules. So based on that, the ABIOC rules will be tailored for your environment. It'll be adjusted automatically to your environment based on the baseline. Okay. Some other considerations here. Deduplication. So every analytics detector will have a deduplication period, as I mentioned, right? Which will suppress additional events. So, for example, for some detectors, the deduplication period will be 1 hour. So it means that only one alert per hour will be triggered. Any additional alerts will be just suppressed. Okay, so we have the same mechanism here for BIOC rules, for ABIOC rules, and even for the analytic rules. Incident grouping. So that's another functionality that uses machine learning, right? XIAM will group alerts into incidents automatically based on the cyber attributes and the root cause of the attack. Okay, so it will analyze based on some machine learning models and then group alerts into an incident. This is important so we can focus right on the attack instead of being lost in so many alerts, right? These alerts will be grouped into incidents. So in the investigation perspective, right, it'll be easier for us to understand the attacks and focus on the incidents that are important. And finally, IP ranges. There's an option on XIAM where we identify internal IP ranges from our network and internal domains, right? So if you go here under assets, you go to network configuration, right? And here we can specify internal IP addresses, so internal IP ranges, also external IP ranges from our network and internal domain suffixes. Okay, so this information is important because some detectors require this information, right, to identify suspicious incoming connections, suspicious outgoing connections. So some detectors will be based on traffic direction. If you don't have this configuration correct, it may create some false positives. And as our network is dynamic, right, from time to time we may have to make changes to this. So every time we make any changes to the internal IP ranges, it may cause some false positives in the first day because the baseline is adjusted every 24 hours, right? So during this 24-hour period that we may have made the change, it may cause some false positives. So in this diagram, we can understand, right, the multiple functionalities that we have here that makes use of AI and machine learning. So as we are collecting logs from multiple sources, these logs, so all these logs, telemetry from the endpoints to be normalized, parsed, stitched into alerts, right? It will generate the causality view based on the causality analysis. Some detectors, some engines will use also machine learning, right, like the analytics itself. These alerts will be grouped into incidents, another feature that uses machine learning, right, to group alerts into incidents based on the cyber attributes, based on the root cause of the attack. And another function that makes use of AI and machine learning is the incident scoring and risk calculation, right? So the severity will be calculated based on the alerts grouped into these incidents, and the score will be also calculated automatically by a function called smart score, right? So the score helps you to prioritize properly. So what incidents are more important to investigate first. So getting to more details on these detection stage, right? As I mentioned, we have on XIAM multiple detection layers. So we have here logs being collected, right? The based on the analytics profiles, the baseline will be established. So we talked about the different profiles. Then we have some detection layers here, right? Not only BIOC rules, there are some other types of rules, IOC rules, BIOC rules, the indicator rules, right? We have also alerts that will be triggered on the endpoint itself based on the protection modules we have there. So they are all detection layers we have here, but these detection mechanisms here are based on the rule-based engine, right? So they are all static rules. And then we have the next layer here, which is the ABIOC rules. So think about ABIOC rules as a hybrid rule, because it's based on a rule, right? But it takes into consideration the profiles. So the profiles here will work as a threshold for the ABIOC rule. So it gets adjusted to your environment. And finally, the analytics detectors, right? So there are some detectors that will require multiple hits. And so it keeps these information, the partial hits, in a state table. Once the threshold is reached, then it may trigger alerts. So it's similar to, for example, remember some IPS rules, for example, to detect a DOS attack, right? So to detect a DOS attack on an IPS system, it will measure the number of packets, so the packet rates per second, right? So it will define a threshold, how many packets per second is considered normal. After that, it'll trigger the alert. So kind of similar here, right? So the analytics detector, some of them will have condition here for multiple hits. So if you have this condition, it will store these partial hits into a state table until the threshold is reached, and then it triggers the alert. Okay. So here we have an example of a profile. So in this example, we have two processes, right? So the entities, a parent process and a child process running on a specific host, right? So the profile will compare, especially the grouping profile, right? Will compare these activities with other hosts to identify the popularity. So how popular these processes are, right? If it finds the same processes running on multiple hosts for a specific period of time, so it means that it's stable, right? It's a common activity that is persistent for a long period of time, then this will be considered normal, right? That's your baseline. Another example of profile is the entity classification that I mentioned before, right? So in here, the XIAM profile will be able to distinguish between a regular workstation and a specific server. It can be even more specific to identify the type of server, a DNS server, a mail server, a backup server, a database server. So it's even able to identify an Oracle database server and a Microsoft SQL database server. It is also able to distinguish between different users, right? A regular user account, an administrative account, service account, and so on and so forth. If you have, and this is important, if you have the ITDR license, these rows for the entity classification will be visible. If you don't have the license, it is just part of the black box, right? You cannot do anything, you cannot visualize. But if you do have the ITDR license, ITDR stands for Identity Threat Detection and Response. Basically, this license will extend the XIAM UEBA functionalities, right? So when you have this license under assets, you'll be able to see the entity classification roles, and you'll be able to customize. So you can add user accounts to specific roles. You can add servers. You can add hosts to specific roles. So you'll be able to customize this profile. That's the only profile that can be customized. But remember, only if you have the ITDR add-on license. And here we can see an example of these analytics detectors, right? Where can we see this information? So you have two ways. You have the documentation. So if we go here to Docs, Cortex, XIAM, we can find all documentation in here. Okay. So specifically for XIAM, we have these analytics reference guide. Okay. So here in this guide, you can see all available detectors. You can visualize the detectors based on the alert name or the data source. Okay. For example, this one, a backup vault policy was modified. So this is related to the AWS resources, right? So specifically this one, we have the time intervals, activation period, 14 days. So it means that it will only start triggering alerts after 14 days of logs. The training period for the baseline is 30 days. Test period doesn't apply. You see here, this is a single event. When you see this single event, it is related to ABIOC rules, okay? Because ABIOC rules will identify a single event, okay? And what is most important here, the required data, right? So it requires the AWS audit logs. We have many here. Let's search for WMI, for example. There you go. Remote WMI process execution. So same here, you have the activation period, the training period, the test period. This is an ABIOC rule as well. The deduplication period, 3 days, so just one alert every 3 days may be generated by this one. And the required data, so it requires just the XDR agent data. Also important, right? I mentioned that every detector will be related to a specific technique, right? Tactic and technique. So here you have the information about the MITRE ATT&CK framework, the tactic that is covered by this detector, and the specific techniques. And if we have also a playbook to handle this kind of alert, right? It will suggest a playbook to run for the automation. Here you have a description of the attack, right? The attacker goals, and some suggestions for the investigation process. Okay. We may have some variations. So this specific detector will trigger alerts with medium severity, right? But there may be some variations. If this process is a suspicious process, so if WMI is used to execute a suspicious process, then the alert, so the impact is higher, therefore the severity will be high. Okay, so you may see some variations like this for some detectors. Another way to visualize detectors is, especially in this new version of XIAM, right? We have an option here under Detection and Threat Intel. And we have this option, Analytics Rules. There we go. So we see all the rules that are available in our XIAM tenant. Okay, so we have the rule name, the severity, if we have any variations, as I mentioned, right? Depending on the entity. We have the status of the rule. So in this view, it's showing only the enabled ones. We can change the filter to show all of them if we have any disabled rules and also pending rules. And it identifies, right, what type of rule it is. Is an analytics BIOC rule or just an analytics rule? And you see here, this specific one, let's see here. This one is internal login password spray. So we can see here the rule details, right? There are some variants for this rule, and you can see the specific techniques used by this attack, right? If you want to see more details, click here, more information, and it'll basically redirect you to the analytics reference guide, right? And then you can see all the details of this attack. So it requires XDR data, and it's part of the identity analytics. So because this is part of the identity analytics, remember, one of the requirements is that we have the integration with CIE configured properly. So that's why, if you look here, the activation is pending, right? So although I have data, as you hover the mouse here, yeah, in this case, actually, it's because we don't have enough data. We only have data from 16 hosts, right? It requires 30. That's the minimum. And oh, yeah. And you see here also CIE is not connected. That's another requirement for this detector to work properly. Okay, that's why it's showing pending. If you look some others here, this one for some AWS kind of attack. So unknown account was invited to AWS organization, right? So it's pending because we don't have data from AWS. So 0 out of at least 14 days of cloud data over the past 30 days is required. So that's why it's showing pending. So the rule is enabled, but because we don't have the required data, it'll just be inactive, right? It's pending. Okay, so we have these many examples. Each detector will have their own time intervals, right? The description of the attack, the investigative actions, the mapping to the attacker, MITRE attack framework, tactics, techniques. Okay. And what is the difference? So we have correlation rules as well, right? That's another type of rule. What is the difference between analytics and correlation rules? So correlation rules are part of the rule-based engine, right, that I mentioned. It's a static rule. It's based on an SQL query. So a correlation rule can be a very complex rule, right? You can create an SQL query with a complex correlation logic, so we can correlate data between multiple data sets. We also have the option to have a drill down query. A drill down query is a secondary query that provides additional details. So you have a main query that will trigger the alert with some information, right? And you can also have a drill down query associated with it that will show the analyst more details, right, to help in the investigation. We have the alert suppression option, right, to avoid any duplicates. We have the MITRE attack framework mapping, so we can map here what techniques does this correlation rule will cover. And as we create these custom rules, right, we can export them and import on other XIAM tenants. So this is important, especially if you are a service provider. You can export your correlation rules, right? Let's say you create a few very good rules and you want to share these with your customers, right? So you can export from your tenants and then import to your customer tenants. Okay, I will not go into the details of the correlation rule. It's not the focus of this session, but these are the main characteristics of the correlation rule. So just to compare and contrast, right? The main differences between analytics and correlation rules. Analytics is part of the baseline-based engine, right? It uses advanced algorithms and machine learning techniques to learn from your environment, identify what is normal, right, the baseline, and then once we have the baseline, we can identify patterns, trends, and anomalies, so any behavioral deviations. So it is used as a proactive threat hunting and detection for emerging threats and focuses on analyzing a huge amount of data, right, for anomaly detection. Correlation rules are some way more simple, right? It's a rule. It can be a very complex rule, but it's a rule. It's a static. So as we have data coming in, the correlation rule will match that data with the rule itself, right, with the query. If we have a match, it triggers the alert. Okay, but it's static. So as we saw at the beginning, if the attacker finds a way to bypass this correlation rule, use a different set of techniques, it may bypass the correlation rule, right? Because it is static. And finally, EAL logs. So what are EAL logs? EAL stands for Enhanced Application Logs. So this is a kind of log generated by Palo Alto firewalls only. Okay, this is a functionality that we have only on Palo Alto next generation firewalls. It provides additional information for the network traffic, right? It extends the details and metadata of the traffic logs, threat logs, etc. Okay, it provides not only layer 3, layer 4 information and the application ID, it also provides the context of the communication. So this is very important, especially for analytics. So just to compare and contrast here, if we are collecting traffic logs, right, using NetFlow, NetFlow only provides layer 3, layer 4 information, right, just IP and ports. So not enough. If you have a next generation firewall, Palo Alto or some third party next generation firewall, it will provide you some additional information like the app ID, what is the application name, right, and user ID, what is the user. But if you are collecting EAL logs, it will provide you the context of the communication. So for example, for this one, it identifies that it's an LDAP query and what the query is. So in this query, it lists all domain admins. If it's a DNS connection or a DNS query, it is able to provide what is the FQDN for the query, right? Details like that. For SSL connections, it may provide the SSL negotiation information, certificate details, the SNI negotiation, and etc. So NetFlow provides you just the tip of the iceberg in terms of data. Traffic logs provides you some additional details like the application name, username, and EAL logs will give you additional details, right, to understand the attack. So let's have a look into a use case. So we are collecting logs here, right, from endpoints, from next generation firewalls, so in this case the EAL logs, and then the XIAM analytics identifies a DNS query to a suspicious domain, right? So as part of the EAL logs, we can see the DNS query details. What is the FQDN for the query? So let's say this is not common, right? So based on the profiles, the analytics engine will identify if a DNS query to this domain is normal or not, right? So based on the dynamic profiles, as I mentioned before, right, it will determine the popularity. So how common is a DNS query to this domain? Is this done by other entities, other hosts, or not? And because of the entity classification, right, it may distinguish between a regular workstation and a DNS server. So maybe a query to this domain is normal for a DNS server, but not normal for a workstation, for example. And then, so after the query, a network connection is initiated to this FQDN. And then we have a file upload action here. Now, also based on the baseline, right, analytics will verify if an upload is a normal activity. So maybe it'll be considered a normal activity if the file size is under 100 megabytes. But let's say in this specific case, there's an upload action of a file with 500 megabytes, for example. So it exceeds the baseline, right? Because it exceeded the baseline, then an alert to be triggered. Okay, so that's why EAL is very important. It will provide deep information, right? Deep details about the network activities. And how do we know if we are collecting logs properly from the firewalls, right? If the firewalls are forwarding the EL logs to our XIAM tenant. Let's say you don't have access to the firewall, right? You are just the XIAM administrator. So I cannot log into the firewalls and verify if the EL logs are enabled or not. What you can do, actually, you can run an SQL query to identify if the EL logs are being forwarded. So in this specific query, we are querying the XDR data set, which is the default data set, right? Then we use the filter for the condition. So we are looking for traffic where we have DNS as an application. So the action app ID transitions is the app ID, right? So we are, in this case, looking for DNS traffic and SSL traffic. Could be anything here, right? It's just because DNS and SSL traffic would be more common, right? So to make sure we get some results in the query. Then as part of the data, we have an array called backtrace identity. So we use the array expand section, right, or stage to extend the array. So expand the array into multiple fields. Then we use another filter stage to get some specific string from the backtrace identity. So as we run the array expand, this array will be expanded into a JSON format, right? So we use the filter to JSON string to extract some information from the backtrace identity. So we are looking for this specific string, firewall.eal. So if the firewall is sending logs with this metadata, it means that we are collecting the EAL logs, okay? Then we use the outer stage to also extract from the backtrace identities the serial number of the firewall. Okay, so it's extracting the serial number into this temporary variable, next generation firewall serial. Then we are going to deduplicate information per firewall serial number, because in this case we just want to see how many firewalls, right, are forwarding the EAL logs. We are not interested on specific traffic details. And fields, the field stage will show you in the output. So what fields will be presented in the output. So here, the serial number of the firewall, the application ID, the backtrace identity fields, and all the fields that contains DNS or SSL. Okay, so let's test it. Let's see how it works. So we go to incident response, query builder, SQL, and let's copy and paste this query there. Okay, so everything is okay. We don't have any errors. Click run. And if the firewalls are sending the EAL logs, we may get some results here. Let's check here. Maybe my firewall is not running right now. I have to check. Let's get data from the last 7 days. There we go. Okay, so here I have one entry. I have the serial number of the firewall. And here is just a sample of a network connection, right? The backtrace identities array. Okay, so it was expanded into multiple fields. And we were looking for this information, firewall e.eal, right? So that's one of my filter stages there to identify into the backtrace identities field the firewall.eal. So it means that these logs are the EAL logs that I'm looking for. Another one here that may identify that we are collecting the EAL logs is this event subtype, extended traffic log. Okay. So my firewall is already integrated with XIAM, just to show you pretty quick here. So we have here data sources, right? Among the data sources I'm ingesting into XIAM, I have the next generation firewall. Okay, so now the next generation firewalls can be integrated directly into the XIAM data layer. So it'll be sending the logs directly to your XIAM tenant. There you go. So that's my firewall. I can see here the connection is okay, certificate is valid, and the last communication timestamp. Yeah, I may have some problems with my firewall because the last time it was yesterday, so I have to check. Or I don't have any traffic because this is just a lab environment. Okay, and that's it for this session. I just, before we finish the session, actually I wanted to show you a real use case scenario for the analytics detectors, right? So let's suppose I'm doing some research, right? Every day I do some research to identify new attack campaigns, right? New techniques used by attackers. What is in the wild? So let's say as part of my investigation, I verified that there's an attack campaign that is using a specific technique called MFA push bombing attack. So I just read an article here. Okay. So what is the MFA push bombing attack? What happens? So this specific attack technique uses what we call MFA fatigue attack, right? So the attacker will send multiple, so it'll push multiple notifications to your MFA service to authenticate, right? So on the user perspective, the user will receive a bunch of notification in his smartphone, right, to approve the authentication. So he gets so annoyed because there are so many notifications, right, that he may think here that this is just a technical glitch in the application, and he ends up approving the MFA authentication just to get rid of these notifications, right? So that's the attack. What is important here to identify is the MITRE attack technique that is used, right? So we have a specific technique here called multi-factor authentication request generation. Okay, so it's T1621. Okay, so we can go back to our XIAM tenant. We go to the analytics rules, or you may go to the reference guide, right? But here is more important because here you can see if this rule is active, right? That's the idea. So let me change the status here to see all of them. And as a filter, I want to provide the MITRE attack technique. So I'm looking for T1621. There we go. So we have a rule that covers the T1621. Multiple Okta MFA requests to a user. Right? So this, when you see a little user icon here, this is part of the identity analytics. Okay, and most important, if the status is enabled, right? When the status is enabled, it means that we have the required data. So we can also look into the documentation to get more details, right? T1621. And there we go. So here we have actually two rules. I wonder why we don't see both in the XIAM web UI. But anyways, it requires the Okta logs, right? So if we are collecting the logs correctly from Okta, this specific detector is active. So we are covered, right, to identify this specific attack. Okay, that's the idea. How we use analytics in the day-to-day, right, to make sure all detectors we need, right, are all active and working properly. Okay, so that's all I have for this session. Thanks for watching, and see you on the next session.